Hello friends, welcome to Unacademy, which is the largest online education platform for GATE Computer Science and Information Technology. Now, myself Mallesham Devasane. In this session, I'll be discussing very important topics for the coming GATE exam, which is going to be static single assignment code and 3 address code as well as control flow graph. These three are very important topics in competitive exams of compiler design questions. Now, in previous session, we know what is 3 address code, what is a static single assignment code, but still you require to understand because if you want to design the control flow graph, you require either 3 address code or SSA code to design the control flow graph. This control flow graph depends on intermediate representation. So if you want to design the control flow graph, you require to understand what is the 3 address code or intermediate representation. Okay. Now, where we use this control flow graph we use in optimizations purpose, or we can use in code generation to produce the assembly code. So to understand this control flow graph, first we will just rewind the concepts of SSA 3 address code, then we'll move to control flow graph. Okay, before starting this, let me introduce myself. If anybody is new to this session, guys, myself Mallesham Devasane, you can call me as Deva sir. I'm verified educator on Unacademy. I teach in GATE and ESE segment for CS and IT. And you can visit my profile www.unacademy.com/@devagatecse. You can use this referral code to access my classes or to log in onto Unacademy. DEVALIVE is going to help you to access the free classes as well as paid classes. And if you look at background details, I worked at various institutes like ESE, ESE, etc. I have completed MTech from IIT Bombay. And if you look at my past experience, I have more than 12 years of experience. I have guided more than 1 lakh computer science IT aspirants who are preparing for GATE. And also I have taken some courses on Unacademy along with my educator fellows. I have taken C programming, TOC, compiler. These three are very popular courses that I have taken on Unacademy. Okay, so this is my referral code DEVALIVE. You can easily remember this code. Deva is my name and you are going to attend the live classes, but not only mine, all Unacademy classes. So DEVALIVE is the referral code to get 10% discount, as well as if you are seeking for the guidance. And this code is really going to help you. And you can also access to all my classes, where more than 350 classes that I have taken on Unacademy freely. They're completely free classes, but just you need to visit unacademy.com/devagatecse. You will see the mixed subject questions and individual classes for TOC, compiler and algorithms, and revision classes, and all-in-one practice as well as guidance classes and previous year questions. And you also have a free test series for GATE, CS and IT. Right, so many free classes you can access on Unacademy. And guys, if anybody is new to this channel or Unacademy, visit this unacademy.com website and log in. Where you require code, then use DEVALIVE if you require the code. And this is your segment, GATE and ESE. Choose the GATE and ESE segment. This is your goal. And if you are interested to take the subscription, click on this. If you want to search on any class or educator, you can do search here, so that you can access free classes from any educator. Okay, if you want to click, if you want to take any subscription, you will redirect to Plus or Iconic. Okay, so now if you are interested, suppose, then what are the advantages of taking the subscription, either Iconic or Plus? Mainly Iconic I am talking about. This is kind of a revolution course in the world, where you can have the one-to-one interaction with educators, as well as you will have a personal coach and a planner and analysis of every test that you attend and study material and all benefits of Plus. Then what you have Plus and Iconic, India's best educators, right? Even though you're using my referral code, you can access every educator class. Remember that. And interactive live classes for every course, structured courses, and you will also get a PDF of every class and live tests and live quizzes. These are the Plus benefits. And what are the benefits of Iconic? You have additionally personal coach, test analysis, study planner, separate study material, as I just told, additional to plus. And if you look at the many more educators are there, and I'm just listing a few educators who are popular on Unacademy. You can see VD sir, myself, Khalil sir, and Satish sir, and Pankaj sir, Sanchit sir, and Guntur sir, and Sweta ma'am, and Venkat sir, and so many other educators who are teaching in Unacademy, who are going to help you in various courses, and everybody is mastered in most of their subjects, and you are going to enjoy throughout your subscription. So by taking the plus and iconic subscription using DEVALIVE referral code, you will get all the benefits that you can go to any educator on Unacademy and you can attend the classes live. So this is the benefit of using plus or iconic subscription. And here the advantage is structured courses from every educator, multiple courses for the same subject, and study as per your interest and learn from top educators, and study with proper planning as per your batch, and enjoy learning without losing confidence. Every day by day you will increase the confidence, because all the educators, they will motivate in every aspect of learning, and you will see the unimaginable journey throughout your preparation. So these are the benefits of taking plus and iconic, guys. When you click on a subscription, you will be redirected to plus or iconic, and if you choose the plus, then you will see the 1 year and 1.5 year, 2 year plans. If you are going for 1 year, 27,225 and 34,650 and 39,600 for even 1.5 year, 2 years respectively. And if you are going for iconic subscription, you can choose 1 or 2 years plan. You can choose, if you choose 1 year, you will see 40,500 after applying DEVALIVE referral code, and 54,000 for 2 years. So these are the benefits you have, these are the plans you have in iconic and plus. And if you are learning from this channel, you have very good educators on this channel. You can learn, and soon many other educators are going to join, and you will be learning a lot from many educators. So keep connected to this channel, guys. So let's start today's session, which is the good evening Satyajit, Kunjal Sharma, good evening. We need to write algorithm, Satyajit. We have a code optimizations. We will learn the techniques, but it depends on how do you think, because we don't have a single algorithm in the world. A number of algorithms are there. So you need to learn the minimum techniques where you can apply the code optimization on the given code. So do not look for any algorithm, learn the techniques and apply as per your knowledge. If there is an algorithm, I could have explained that algorithm already. Anyhow, now please like this session. Please like this session before starting the class. Fine guys. Okay, let's look at what we have seen in the previous class: introduction to compiler, lexical analysis, syntax analysis, and syntax directed translations. In the previous class, intermediate code, intermediate representations, right? Now we are going to see 3 address code and SSA code, and then control flow graph. Then I'll repeat again 3 address code and SSA code. How can you write the best 3 address code and SSA code? You need to apply your own techniques to understand, but without code optimization techniques, maybe it's very difficult to identify how many number of variables are there minimum in the given 3 address code, or writing 3 equivalent 3 address code. Okay, in the previous session we have seen postfix code and 3 address code, SSA code, syntax tree, DAG, and we are going to introduce today control flow graph too. Now let's look at this is already a 3 address code. This is already a 3 address code. Now somebody might ask you, how many minimum number of variables I require for the given 3 address code? For the equivalent 3 address code we can write. This is given to you, and the question is, how many minimum number of variables in equivalent 3 AC, 3 address code. how many minimum we want. So if you want minimum, guys, first best thing is write an expression for this, because you do not know, some terms can be cancelled here. If you get something like that, plus b minus b, 1 after that, you can cancel them, and some kind of cancellation simplifications can be observed when you write an expression. And second thing is, while reordering the statements, you can also reduce the number of variables. So reordering and simplifications can be done. That is the reason better to write expression first. Write expression so that you will understand what kind of 3 address code which is you can write for the given 3 address code. Okay. Now first, you need to go from bottom to up. So I am doing that. T4 is equal to T3 plus T2. And what is T3? That is T1 star T2, you have to substitute. Plus, what is T2? And you need to substitute A star B. And now we have two things. Here you have a T1, T2. Both you have to substitute. We have T1 as well as T2. So what you get, T1 is A star A plus, star. T2 is A star B plus A star B. Yeah, this is T4 is equal to. Now sometimes you might require reordering of the expressions. You can do that calculation, reordering the expressions or calculations, that you can do it. Here cancellation can't be applied, but sometimes instead of calculating A star B, you might require to calculate A star A so that you can reduce the number of variables. So now I'm trying to focus on A star B. Now I'm writing 3 address code. First I will focus on A star B. Yes, you can do that. So I'll write a T1. That means you are going to get T1 for this. But why do you want unnecessarily temporary variable? Can I do using A or B? A you can't do, but B you can do. The reason is B is free from here. After this, because here 2 times A star B is required, you calculate, you can reuse it. So I can now reuse a B in place of A star B. That means I don't need additional temporary variables for calculating A star B, because B is free just after this. So I can reuse a B again to rewrite. Now B I have. Next I have A star A. When I am calculating A star A, then A is free now. B is also already freed. So B we have occupied. Now A I can restore and I can rewrite. I can define it. So I'm using A. Now you can do calculation A multiply with B. A multiply with B. Now B is required in future. So I can only use A now. Now this is your A. Now A plus B. That now right now everybody free, I'm using A. So this is the best 3 address code where just 2 variables enough, no temporary variable I have used here. And when you look at this code, you have A, B, T1, T2. Here given one as a 6 variables. Have you seen how many variables we can use? And that you will understand when you write an expression for that. So first write an expression. Look at, is there any possibility of reordering? But if you do A star A first, guys, you require temporary variable. That's called as reordering. You can calculate anybody is the first, either this or this. But if you do this first, we can save a less number of variables. We can have minimum variables. And how do you know that? That is by understanding, that's all. If you do this first, then what happens? In future, A, B both required. So you can't write into A or B. So you need more variables. So you need to do reordering. Remember that. In the given code, they were actually doing A star A first, then A star B. But we can reorder them because these two are independent calculations. We can reorder. So that you don't understand in the given code. So this can be reordered. and you need to have a much practice to understand that reordering. And reordering is very important in optimizing the given code too. If you want to have the less number of variables, you need to reorder the code, right? This is the first technique, reordering and simplifications and other thing. I hope everybody understood. Yeah. Now this is about 3 address code. Now we have the another code. Now I want to write something. How many minimum variables are required for this SSA code? If I ask for this 3 address code, then what do? You just do the second question. Question 1 is over. Same question if I ask how many minimum variables in SSA code, then what do you do? What do you do after this? You need to write. This is the 3 address code. Now you need to write SSA code. How do you write SSA code now? Just after getting the best 3 address code only you can do that better. How do you do? A star B. And that B is already there, so we rename it. But this is connected here. Remember that. This one and this one. So there you need to write B1. Next you have A multiply with A. Then I'm using A1. So this A1 connected here. So A1 multiplied with B1 you are going to store in A2. And this A2 connected to here. And A2 multiply with B1. Now you have to store in A3. So if you look at the SSA code, you require A, B, A1, A2, A3. So you require 5 variables to represent best SSA code. And if you want to write SSA code, always it is a good strategy. Write the best 3 address code, then name the variables to understand what is equivalent SSA code. So that is the best strategy. Fine. Now let's move on. Now somebody has given 3 address code. Now I want to write equivalent SSA code. Now don't do it directly. So what do? Best same approach. Write expression and write best 3 address code. Then write the best SSA code. Because best 3 address code always guarantee best SSA code by renaming the variables. Now in this process, first write an expression. When you write expression, you always have a strategy. What strategy you have? You always go from bottom to up to understand, do you have any useless statements in the code? T2 plus T4 and focus on what is T2. That is A plus T1. What is T4? D plus D star T3. Now we have T1. What is T1? Here T1 nothing but a B star C. A plus, that is B star C plus, and D is fine. T3. What is T3? What is T3? B star C. And now A, B, C, D is there. There is no temporary variable. That means no more substitutions, guys. No more substitutions. We have done all of them. Okay, now we have an expression. You can look at now. Okay, B star C calculated twice. In between B and C not updated. So I can reuse that variables. Reuse that expression or calculation. Yeah, guys. Okay, I'm trying to do now the same thing that I'm expecting. So B star C I'm going to calculate once. That after this, if you look at B and C, both are free. You can choose anything. So B I'm choosing because in future B is not live. So I can use B. Now what I'm going to use? A plus B. After this calculation, still B is required. Now A and C are free. So I'm calculating into A. So I'm storing into A. And now I'm calculating D multiply with B. But after this, D is free and C already free and B is free. Now I'm using just B. And now A plus B. After this, no variable is live. So you can use as you want it. I'm using A. But many equivalent codes, guys. but the best code always has here A, B, C, T, 4 variables only. 4 variables enough to represent the 3 address code. But question is about SSA code, right? 3AC. 3AC is a 3 address code. Now SSA code is also 3AC, but the same variable should not have more than one definition. Yeah. Now how to write equivalent SSA code? How to write equivalent SSA code? And you have to look at here A, okay, let me write A, B, C, D. These variables already have a meaning before coming to this code, and nobody can redefine these variables. So here you have a B. This B you need to rename. So when you rename, this one will be renamed and this one also renamed. But look at this B is different and A1. So this A1, and if you rename it A1, then so better to rename in SSA code, right? Why do you want to rename here? Just look at the dependencies only now. Just look at the dependencies now. The renaming we do in SSA code, not in 3 address code you wanted to write. A, you have a dependency here, and B, you have a dependency here, and D was coming from out, and A, B, C, D initially they are coming from out. So B star C, you can't write into B, so we write into B1. So look at now, B1 is here, B1 is here. So better to write immediately to avoid the mistakes. And A, now when you write A1, the A1 we are using in the last statement directly. And D is coming from out, but B you can't do, B2 you have to do. B1 already used. So B2 and A1 plus B2, now you can't write into A, you can use your own name A2. So if you look at this is SSA code where every variable has a single definition. A, B, C, D, they are already having a definition before coming to this code, and now we have defined B1, A1, B2, A2. Total 8 variables required in SSA code. That is the best representation, guys. That is the best representation. That is the best representation. And look at how difficult it is. And those people who are thinking about 3 address code, SSA code definitions are easy. But to write 3 address code or SSA code which has less number of variables, first you need to understand, have you taken a program or expression? Here expression already difficult. If I give you program, you will be looking at here and there, which will confuse a lot. For that reason, we require code optimization techniques to minimize your code, which may take less space or less time. Okay, so you are worried about minimum number of variables. It's about the space. It's about the space. But if you are looking at whole program, we might worry about the space or time. Fine. Now 3 address code for if-else statement. Actually, internally, you have a different code for 3 address. Now you can look at x less than y, actually calculated as an expression. You can see that it is stored in T0, and if Z is the internal instruction 3 address code, you can assume that because which is going to match with one of the assembly code easily. So if T0 is going to have 0, then we will fail. We will go to else part. Yes or no? If this is x less than y is a false, we go to else part. So that's why we have written go to L0. So we will go to here. That's else part. Else part. If it is not 0, definitely will come down. So Z is equal to x, we will execute. After that, anyhow, we should go to this statement. That is a go to L1 again. Go to L1 means we will go here. In case else part executes, after Z is equal to y, we will go to the same statement and we will execute the last one. So this is the if else execution, guys. If else, the equivalent 3 address code. Everybody? So this is the 3 address code and this is high level code. And most of the time we take high level code, but sometimes in the exam they might give which is the equivalent 3 address code. You must be in a position to understand, okay, this is 0. Then we'll go to here. That is if Z. If Z means if 0, then is T0. This is a T0 is 0. Then we'll go to this state else portion. This is the else. This is the else. Okay, so this is about if else. Now let's look at another code, which is while statement. While statement, let's understand. First we will enter this one, same condition, x less than y. We have computed separately in t0. If that t0 is 0, directly we go to this one, that is a false. If z the t0 has 0, then we'll go to L1, directly we'll go to last y is equal to x. But in case true, we will enter. That means automatically we execute x is equal to x star 2, and we need to write a go to so that we can come back to the same statement. So go to L0 will ask you to go here again. So that it is a loop now. It is a loop now. How will be a loop? First you will execute this one, and if L0, that is a false, it goes here. That's L go to L1 statement. Just after L1, y is equal to x is there, and if true, we will execute x is equal to x star 2. Go to L0 means we will come back again. So it's going to create the while loop. It's just going to create the while loop. The entries also you can define like this. If it is false, we go here. If it is true, we come here and we will repeat. Okay. So this is we have written go to L0, and this is we have written go to L1, because we need to jump to the some other location. Okay, this is about the while instruction, while statement. This is the high level code. This is high level code for while loop. This is 3 address code, guys. Fine. This is about how do you write a 3 address code, but really don't worry much about it. In the exam, they will be given to you. Only we need to observe. Then one time they have given the 3 address code for the 3-dimensional array, guys. Most of the people, they did not understand because they don't know how to calculate the address of an element. So here, how do you calculate address of, if you want to access A of ij, base address plus that size of the row, n2 is the size of the row, remember, multiply with li rows and j elements in the present row. So this is going to be calculation of the address of an element. You might be calculated in address. In C language also we have seen that, how to calculate address of an element in 2D. So this is about the declaration. N1 is the size of each row. N1 is the number of rows, and N2 is, you can say, size of each row, or you can say number of columns. Number of columns in terms of elements. If you want a size, just multiply with the size of each element also. So if you know the number of columns, you can find out the size of the row. Fine. So now A of ij, this is your high level code, but equivalent 3 address code, you look at, this is the complete 3AC for accessing A of ij. Remember that. How do you do that? First, you need to calculate the n2 multiply I. So we have calculated, because that's the one instruction. It's going to calculate how many elements are there before the present row while accessing, and then t1 plus j, that is going to calculate this much, and total number of elements before the present element, then this is exactly size, because we are going to calculate the addresses here, t2 multiply with w, this one. So we are calculating something like this is the t1, this is the t2, and this is the t3. And best 3 address code later on you can write to minimize the number of variables. That is later job. Equivalent 3 address code I am writing. And then t4, assume there is a base address is there, t4 base address. Now calculation t5, nothing but the t4 of t3, that means t4 plus whatever the t3, that's calculated at runtime how to access the element. So this is the equivalent 3 address code, but is it the best 3 address code? No. Number of variables you can minimize, depends on your program. Here you can reuse I and j if the job is over for ing. Okay, this is the 3 address code, guys. If you are watching this video, and please don't forget to like the session. Please like the session. And basically I'm explaining very basic things, how to write the 3 address code, because in previous gate question they are asked 3 AC for the 3D array, 3-dimensional array, guys. At that time people confuse a lot how to understand the given declaration. Okay, they have given everything, they asked which declaration they have given. Okay, here W is the size of each element. If it is integer declaration, then we will write size of int or size of char if it is a character declaration for each element. Fine. Now let's move on, guys. Don't worry much about it, and that is given to you every time in the gate. Only you need to cross check. And if anybody not aware of plus, guys, you should know that you will have live classes for every subject, and you are free to attend any educator course, and you will have crash course, long-term courses and short-term courses and revision batches and test series. So many are there inside the plus. All of them are free completely once you take the plus subscription. And what is the benefits of Iconic? Superset of plus. All the benefits of plus, and additionally we'll have a personal coach, study planner and study booster sessions and personalized test analysis and a separate study material for Iconic. So these many benefits are there for Iconic subscription, guys. Okay, if you have any doubt, you can approach me all the time. Guys, please like this session, which is very important. If you are not interacting during the class, obviously you are going to suffer. Anyhow, I'm taking the class and I'm going to complete my job. But keep interacting, say something if you are attending live classes. Okay, if you are watching the recorded, please keep commenting after watching the video what you have learned in this video compared to any video outside this YouTube channel. And definitely you will see the difference of our videos and other videos. And so far we have seen the videos, and those are, what is the content of every video. And here we come up with the required content, and we do research before delivering the class, and most of the time 99% the content is useful. And please follow these classes. Never get a doubt, is it enough or not? Remember that. If you are attending Saturday, Sunday classes and Monday to Friday, and it's also sufficient for learning the content. Okay, control flow graph, and where the code optimization begins, guys. Now I have not kept the heading of code optimization because I'm going to help you again and again how to understand the control flow graph. So what is the control flow graph? This control flow graph will help you to do the code optimization, used in many cases. Code optimization to optimize the given code, and also used in code generation also to produce the assembly code. So code generator can also use the control flow graph to produce the equivalent assembly code. So the control flow graph is going to analyze the whole program and is going to maintain the basic blocks. It is a group of basic blocks. Whether you give a program or a function or a state or a set of statements, it is going to make the basic blocks, and there will be nodes and edges that to define basic blocks and controls. So main focus is on basic blocks and controls, but somehow we'll create the nodes and edges. So we are going to understand slowly what is the basic block, what is the control, what is the node, and what is the edges. What is the edge, guys? Is that clear? So we are going to understand. Let's start with what is basic block. Let's start what is basic block. Okay, so basic block is a sequence of instructions like I1, I2, I3. The sequence of instructions, if you group them into a single block, the control only enters before I1, control only just leaves after I3. In between, no control should enter, and in between, no control should leave. Remember that. Only control should enter I1 because execution is sequential within this block. And this is the maximum sequence. Remember that. Basic block is a maximum sequence. Right? What is I1, I2, I3? They are 3 address codes. Any intermediate representation, you can write SSA code also. Any intermediate representation you can write. This is IR only. Sequence of intermediate representations. So any basic block is the maximum sequence where you can put in one block, so that the execution is a sequence and control only enters at the first statement and control only leaves at the last statement. So all of them you should remember. Then this is called as a basic block. And your program is divided into n number of basic blocks, depends on the controls. We'll see how to make a basic block soon. But try to understand, here there are many names, guys. Here I1 is called as a leader. So the control only enters at leader, guys. So control enters only at the beginning of sequence. It means only at leader of the block. So every block has a leader, only control enters. So in between, directly I can't execute I2, I can't execute I3 directly. So you must start from I1, right? Then how do I know I should start from I1? So we are going to make for the given program, and control leaves only at the end of the sequence. Then where this control goes, this control can go to only leader of any block. Any control that leaves any block, that must go to leader of any other block. So also remember that. We are going to continue this. Okay, let's move on to make the basic blocks. Now look at, I'm trying to understand, this is the given 3 address code. This given 3 address code we can represent as a control flow graph, intermediate representation, that is, guys. But that is 3 address code. Now I must understand how the control enters at every statement so that I can make a basic block. Look at, guys, control enters from here. That's by default. Yes, and look at that. Now after executing this statement, go to L2, means this control can go to directly out. Otherwise control can enter. So here understand S is equal 0, I is equal to 1. If I greater than n, I can keep go to, you know it, right? Go to means is basically a control. And L2, maybe that L2 comes later on where control leaves. Now, and then control has two choices. Either it can come here or it can go to somewhere else. And next, look at control after T is equal I into I, S is equal S plus T, and control going in a sequence, guys. And these 3 are executing sequential, and these 3 are executing sequential, remember. So we can keep in one block I into I. After that, immediately always S plus T, I is equal to I plus 1. And even though always go to L1, but L1 is not having just immediate, it has to repeat. Look at that. Oh my God, L1, somebody enters here. Oh, not possible, guys, not possible. I was kept at one place, but what is happening here? How can I go to this one? Impossible, guys. Control never enters in middle of the block, right? So we have to divide here. Guys. So now I'm going to separate that. So how I'm making this? For that, I require to understand all the controls. Let me help you again. First time, design the controls, guys. Okay, control enters. Now this control goes here. And just keep the controls. Then look at how the controls go to L1, this one. Now look at, if you want to make one block, these 2 are in one block, because at 3 or at L1 the control enters someone. Someone is entering there and someone is also leaving there. So what do? S is equal 0, I is equal 1. If you keep these 2 together, no control enters in between. So control only enters and at the begin and leaves after I is equal 1. Yes. Now if I greater than n, then we go to L2. Now control leaves here, no doubt. Okay, I'll write later on. T is equal I into I, and S is equal to S plus T. Now in these 3 statements, the control never enters in between and control never lives in between, but control lives only at here. Go to L1. So now I can write here, go to L1, because this is L1, this is L1, L1 is this one. So I'm going to make the basic blocks like this. L1, go to L1, go to L2, they are just edges, guys. Now I greater than n, it goes directly out, so return S. It's another statement, let's say a special statement here. Everybody, now look at the basic blocks here, and how many basic blocks are there? 2 and 3, 4 basic blocks, guys. Every basic block you can see the execution is a sequential. Nobody enters and leaves in between, right? So here every statement in a basic block, every first statement is called as leader. What is the leader here? The first statement of the basic block is called as a leader. First statement of every basic block is called as a leader. Okay, guys, looks like yeah, I don't know why people are disliking. Are you getting the point? Okay, the facts are always difficult to understand. Okay, leader. A leader, nothing but the first statement of every basic block is called as a leader. Then what is the advantage of leader? The control must enter at leader. Any control leaves, that must only come to the leader. Look at this one. Okay, let me write this one. Look at this control is going to the leader of other block, and this control goes and enters the leader of another block. So this control leaving from that block but going to enter leader of some block. So any control that leaves, every control means basically edge, guys, here, but these edges are controls. Every control enters only at leader of basic block. It can't jump to any other. And any control that leaves from any basic block, must go to a leader of some block, same or different, doesn't matter. Go to leader of some basic block. Everybody? So these are the two statements that I am talking about. What is the basic block? All these points are important, guys. All these points are important. See, if anybody asks how many basic blocks, 4. But how many nodes and edges? Very dangerous, guys. The reason is there is something is missing. I didn't mention it, but you have somebody else here. Start. And this is not a control, this is edge. And here there is an end. Because after that we are going to stop basically. We always do something start and nodes, because there they are going to define something. And here if anybody asks number of nodes and edges, just what do you require? 1, 2, 3, 4, 5, 6 nodes. But how many basic blocks? 4 basic blocks. Mostly written word may not be there because they always ask for expression if any comparative question comes. If you ask edges, controls are how many? You can look at 1, 2 and 3, 4 controls we have. But how many edges? Edges are more here. You have 2 extra edges, that are 6 edges. And do not confuse ever control flow graph and flow chart. Flow chart is different from control flow graph, guys. Flow chart is different from control flow graph. Flow graph. Flow chart is different. So most of the people, they are not aware of control flow graph. They keep drawing similar to flowchart. So that's going to be a mistake for you. Here basic blocks are different from the flowchart. The nodes, their nodes are represented with rectangle and diamond box and so many are there. So but here we don't have such representations. Here basic block we just have, and remaining are controls or nodes and edges. Fine guys. So this is how we draw a control flow graph. Fine, let's move on. There is another question. Okay, you can try as homework if you want. I will do it. So I want to draw the control flow graph for this. So how do you do it? Automatically you enter here and first try to understand how do you execute sequentially. Here go to statement is there, L3. So you must go to return M. And then if not, then definitely you go down and you execute this. And go to L2. So L2 in the sense, you will go to this statement. And return F2. Return F2. And that means the control goes directly to out. Directly out. And return M is also goes to out. Assume that way. And the control not leaves from here. And if anybody comes to L2, it executes like this in a sequence. And go to L1. This go to L1. It's going to enter here. Right? And this control you require to understand. When you are combining here, you must know how to combine. Look at that. If I am starting here, I can keep this up to here as a one block. How do I know that? How do I know that? I can keep in one block because after that only control leaves and nobody enters. Then I have to make I equal to 2 separately, because if I less than M, somebody coming to that, so you can't mix up. And this one has to be separate because somebody coming to this, somebody leaving from here. Both are happening, so you have to keep separately. Anyhow, return F2 is separate. Yeah, can I keep return F2 with if I less than or equal to M? Because in between nobody entering, right? But in between go to L2 is there, so you can't mix up. That is another problem. So return F2 I'm keeping separately somewhere. And next, if somebody coming to L2, I can mix up till go to L1, because at go to L1 only the control leaves. Nobody coming in between, and return M separate. So now how do you draw the graph? Look at that. 1, 2, 3, 4. The statements you can mix as one, and then I less than 2. This is the fifth one. Okay. Then you have 6 alone. Then 7 you can keep here or anywhere, doesn't matter. So I'm keeping, there are 2 choices from 4th. It can go to L3 also. So you need to keep on. After 6, there is a chance to come to 7 also and go to somewhere else. There is another control here. I'll write that later. And if anybody comes to L2, they should start executing 8, 9, 10, 11. 10, 11, 12, no need to specify. That we can specify even with the control. And then 13. Okay. So if you want, start is another node. It is not a basic block node. And stop or return, something like that. It is end node. So now let's look at the controls. And this is the sequence I made. Now we need to understand the controls, are they proper or not. At 4, you have go to L3. Where is the L3? That L3 is a 13th node. So that control goes here somehow. Okay, enters. And then after fifth, that next one is just 6. There is no jump from there. But from 6, either goes to return F. Return F, it's directly end after this, remember. But from 6, go to L2. Where is L2? L2 is the number 8. L2 is the number 8. So we can go there. Go to L2. Then 8, 9, 10, 11, 12. After 7 directly we went out. After 12, go to L1 directly. Go to L1. L1 nothing but 6 guys. L1 nothing but 6. And then 13. Who comes 13? From 4 we can come to 13, and after 13 you can stop. So you can look at number of basic blocks required. That even start means always happens at 1. So how many basic blocks you have here, that you should note down. This is the basic block 1, assume that. This is the basic block 2, and basic block 3, and 4, and 5, and 6. Total 6 basic blocks here. And then how many nodes you have? 8 nodes we have, because start and stop also we have to introduce. How many controls we have? Controls guys, count the controls. Okay, all the blue lines you can assume they are controls. Remaining are just edges, including the controls. So compute the blue. 1, 2, 3, 4, 5, 6. Okay, this blue line is obvious. So don't compute the edges that goes to stop and that comes from the start, except that calculate all the edges. 1, 2, 3, 4, and then 5, 6. That's all. Yes, 7. This one. 7 controls we have. You can use a jump for them, and then obviously somebody has to stop, so you can use that are edges. So I'm just saying that 1, 2, 3 additional edges, so 10 edges. Mostly here what is important? Number of nodes and number of basic blocks, and others are very easy to represent, edges and controls, but don't worry much about them, and you should know how to compute the basic blocks. And then nodes obviously +2 happens. Okay, this is about the control flow graph for the given example. And similarly guys, you can try another one. You have an homework here. Take this homework and try how to find out the number of nodes. This kind of questions will come. So here there is no return statement, there is no start and stop, and this kind of simple code will be given to you. This is just a block, this is a set of statements of particular function basically. So there is no return statement here at all. Now for this, how many basic blocks are required? You can compute as an assignment how many number of basic blocks. And after this, for this very easy to compute number of nodes and edges. Number of nodes and edges. A number of controls not required. Every control you can assume it is just like a jump. In the code you can use a jump in assembly code if you have the control. Okay, so this is the assignment for you. You can yes, if for a given 3 address code, it is always unique if you have the same code. If you change your code, then obviously control flow graph may change. For the given 3 address code, the control flow graph uniquely you can represent. Remember that. Yes, that's true. Okay guys, I hope you understood the basic things required for 3 address code, SSA code and control flow graph. And these 3 topics are not gonna be easy for the beginners. The reason is to find the minimum number of variables, you must convert given, whatever is given, you need to convert it to expression so that you will understand how to simplify, how to write into 3 address code again. And SSA code also same problem. And control flow graph here, how do you design a basic block? That's going to be difficult for many people, because basic block, they assume something like set of instructions. That's not enough. That set of instructions should be maximum so that no control enters, no control leaves in the middle of the block. Right? Don't keep 2 or 3. You need to keep the maximum sequence of instructions where all the instructions are executed in a sequence. Control only enters at the leader and leaves at the last statement of the block. Yeah, so that's important here. And in the next class, we are going to start the code optimization. Soon we are going to complete the compiler design, guys. Keep following this class. I know most of you are starting following from the beginning, and keep continuing till the end to understand the subject. and this is my profile. If you want to understand more than this, you can always come to Unacademy. You can search for the classes, you can learn from me even freely or paid courses. And if you are taking the subscription, do not forget to apply DEVALIVE referral code. And advantages, I used to tell that what are the advantages you have. You have top educators, and you can learn from any educator once you take the subscription on Unacademy. It's a completely free inside everything, and only you need to choose the number of months or number of years that you want to take the subscription. And this is our Telegram channel to follow us, and every day we'll share our links on this channel. And we have so many free YouTube channels on from Unacademy, and these YouTube channels are taken, or we are going to conduct the classes with the help of top educators. And please refer to your friends so that they can also learn from us. And thank you so much for attending this session, and do not forget to like the session. Okay, thank you so much, and also share if you enjoy these classes, and subscribe if you have not yet done. Yeah, thank you so much. Bye bye, take care, see you in the next class.